Okay, hello everyone. Welcome to the 75 meeting of San Diego Superbus Meetup. Thank you for coming. Thank you for joining. We have a special guest today. So let's get to it. So if you're new, welcome. We meet every month, usually Tuesday, usually the second Tuesday of the month, but usually Tuesday. If you would like to uh, present anything, approach me. We'll get it set up for you. It's really fun to get a subject, and it doesn't need to be whole hour. It can be 10 minutes, 15 minutes, 20 minutes, whatever you want. Uh, that's something that I would more than happy to work with you on that. So let me know if you would like to present anything here on in the group. We have 1,842, like 1,842 members. At least that's what I was counting last time. So welcome new members. That was the last count last month, the 1,792. A word from our sponsor, JetBrain, is sponsoring San Diego C++ Meetup. So thank you, JetBrain. I really like your Sea Lion and your apps. Thanks for taking care of us and supporting the community. Okay, so I told you that I have a very special guest today, and this is Mike Shah. So Mike, I'm gonna skip the abstract and let you do that. I'm just gonna present you, our guest. So Mike is currently teaching faculty at Yale University with a primary teaching interest in computer science, computer graphics, and game engines. Mike's research and interests are related to performance engineering, dynamic analysis, software visualization, computer graphics. Along with teaching and research work, Mike juggles occasional consulting work as a 3D senior graphics engineer in C++ and producing programming content at his YouTube channel. Welcome, Mike.
All right, thanks so much for that introduction. And thanks everybody for being here. It's very exciting. And this is an awesome group that you have here at the San Diego C++ Meetup. So I encourage folks, as mentioned, to give talks, participate. And yeah, these are often the talks that you'll see before conferences or just not anywhere else. So definitely keep coming to this meetup here. So again, thanks for hosting me. And I'm going to be talking about, as mentioned, how to understand large and unfamiliar code bases today. So a topic that's maybe something that you can relate to if you're working at a company with a large code base. And I will try to keep this interactive. I do have a second monitor where I'm watching the chat, so feel free to ask any questions and I'll repeat them in the recording. Folks can't hear me or see something, please also let me know. All right, so with that in mind, you've seen the abstract, you know a little bit about me, so you can check out more information. And my slides, the important note here, I'll post sometime later today on my website. Just Google my name and you'll find the San Diego C++ talk here. So as I mentioned, I did want to make this a little bit interactive since you're with me on an evening or right after work here. And feel free to type in the chat. I'm just curious, what's the biggest code base folks have worked on? You can kind of approximate it if you want, if you don't have an exact number, but you know, the largest number of lines of code you've maybe looked at or worked on, or allowed to say that you've worked on. What have folks worked on as far as large code?
Few hundreds of thousands, I would say.
Few hundred thousands.
Yeah.
Yeah. What about some other folks? Large code base in the scale of hundreds of thousands. Probably if we have folks that are sponsor at places like JetBrains, you know, they're in the hundreds of thousands or millions of lines of code. Yeah, I see other folks with 100K. I mean, this is what we're calling pretty large, I would say. You know, from some of my experience at Sony, you know, a video game, if anybody, you know, plays video games out there in the West Coast, you're looking at millions of lines of code, maybe 1 or 2 million lines of code for a video game. I'll give you a few reference points here. But the follow-up question for folks is, on those large code bases, did they ever get smaller? Did they ever get less complex over time? I mean, typically when things grow, there's complexity. The other question is, how well was that code base documented? Did you have internal tutorials? Were you at least talking about making them? Wiki pages, maybe videos if you're lucky enough on how some of your code works. These are some things that often, our code just keeps getting bigger and bigger. So we have to understand how to manage this complexity. And I wonder too if anyone had this experience where maybe your code base just grew so large where your team just said, hey, let's just scrap the project and build it from scratch, either because there's design flaws or we don't want to deal with it or everyone's too afraid to touch the code. I've had that feeling, but I've never been able to convince management to, and wisely on their part, to just throw away a bunch of work, even though it can feel like that. So we have to deal with, large code sizes. That's just the world we're in here. And as the comments are saying, the code complexity gets larger. We have different languages mixed in. And again, here's just some reference points here, depending on how you're counting applications. Again, we're in the millions of lines of code here that make up our various technologies. So again, operating systems in the tens of millions of lines of code. Companies like Meta or Google, I've heard rumored anywhere from hundreds of millions to billions of lines of code in their entire repositories. Again, you get the idea here that things are quite large. So again, as a reference, what does a million lines of code look like? Well, about 14 of these books here stacked on top of each other. So, it's large enough that we can't really keep all of it in our head. I mean, we could read this story, for instance, or 14 versions of these stories and keep some of the high-level details, though, which, to a point that's what's important, to be able to know how to navigate and keep some of the high-level details. And we have a comment here about AI. I'm going to address that briefly because I think that's going to be an important point of it. That's sort of in the future here. You could imagine asking AI to summarize this text by Leo Tolstoy and say, what is it about, or what's a specific character? And again, these are going to be some tools that are going to be helpful for us. So with that in mind, I've talked about, I guess, the size is a giveaway, but what do other folks think? What makes a code base hard to understand? From either your experience or, what you might assume might make it hard. And I do see a comment from Paulo. They're saying that, one of their code bases is hard now because there's C++ 20 mixed in, right? You might have different versions or a larger subset of the language mixed in. Another comment, lack of structure. Yep. So again, maybe things were just thrown in. That could mean the physical structure, like the directories, or just the actual logical structure. Confusing variable names, absolutely. So things aren't named appropriately or consistently, that's a problem. Unless comments documentation, yep, you got it. So, for not saying the why, maybe some code, or having a history of the code, these are all things that contribute to complexity. It's excellent. So, I think you folks have gotten the main points here, which is great. But again, understanding what the actual program is doing, what's the structure? So sort of building that mental model. That includes things like what functions are doing, as well as where the data is actually flowing. So I could think about this in sort of two different ways. Do I understand where I'm starting my program, where the entry points are, what the next function calls are in a relative sort of structure or pattern, and then as well as the data. And there could be other architectural patterns, things like threads, fibers, thread pools, job systems, all these certain things that affect the control flow of how data is moving around, how state is changing, and so on. And then, of course, as you folks mentioned, things about function naming and parameters and just an overall consistency is really important. Again, pure scale, as mentioned, so we don't need to mention too many times, makes things complex. And as someone also touched on, mixing in C++ legacy code with, new C++ 26. I think folks who are using C++ incoming 26 features, things like trailing return types, auto, these types of things mixed with a legacy code base where you don't have those things. Again, it's going to look like two different languages. So that can add a lot of complexity. And of course, there are human factors to deal with. So again, someone mentioned structure or lack thereof. These could be things that affect how our code complexity is. So again, the organizational structure, there's this famous law. How many folks have heard of Conway's law before? Basically this idea that, well, however our organization or team is divided, that sometimes mirrors how the actual code or the product is designed. Has anybody heard of that? There's been a couple CPPCon talks, and I always think of Titus Winters, who mentioned this first, or where I heard it first from him, about this idea. So it's something to be aware of. And sometimes it makes logical sense, but what happens if that team structure changes and your code structure will no longer mirror your team? So again, things to think about there. And an interesting comment that Conway's Game of Life folks have heard of, yeah, but not the law. And Conway's law, the first lectures of game theory. Oh, interesting. I'll have to take a look at that. I hadn't heard it from that angle before. Very cool. So anyways, these are, the three things I kind of want to focus on. Now, before we get into the meat of the talk, where I'm going to show you some tools to wrestle with these things, why do folks think I'm talking about this topic? Maybe if I back up for a moment, why should we talk about code complexity and tools for understanding our code? And feel free to just shout it out. Yeah.
I think it makes sense given that graph you just showed us a couple slides ago, as like the bigger corporation. Well, it gets bigger and bigger and bigger and bigger.
Yeah, our code's probably not shrinking. I think we're going to have more and more code, more and more coders. Yeah, this is a very important problem, I think, to wrestle with. And as folks are also mentioning, there's AI and so on. Whether that's code that we write or maybe it's going to help us understand code, that's another factor. Another comment here saying that most programming is maintenance, not exactly greenfield, and that's absolutely something true, at least from the perspective that I'm going to bring up my next point of, when you're joining a team, usually you're working on somebody else's code, right? So we need some tools to understand things. And another comment, to make better systems and help future engineers. Absolutely. So all these things we talked about that can be problems of making code complex, variable naming, code structure, and so on, are things that we want to keep in mind as we grow experience to make our code base better, help the other future engineers, and ultimately probably produce better software. All right, so you kind of get the idea here. And really this talk is just born out of, from the abstract, my own fears as a junior engineer, when I was first joining projects and saying, a million lines of code, because I can't really comprehend that. And it just sounded so scary. So again, today I want folks to leave with a few tools, to help them with this. So again, this is just kind of from my perspective. And today I still work on, short-term projects where I have to jump into a project and ramp up, so to speak, very, very quickly. And again, we don't want to admit it, or at least I never wanted to previously. Now I'll probably admit sometimes when I go to a project and say, I have absolutely no idea what's going on. I want some way to wrestle or manage that complexity and not be afraid to ask some questions, have some tools to help. And yeah, there's another comment about this. A lot of the code that we're writing or maintaining is almost impossible to recreate. The note talking to the COBOL folks. Not many new COBOL programmers are coming along, for instance, but we do have to maintain that software. All right, so there's another reason I want to give this talk, and it's because we often don't learn how to read code. And I'm a professor, so in part, this is my fault, but I'm not blaming schools for this because we have a lot of stuff to learn in school, right? When we're learning algorithms and complexity theory and these types of things, if you've gone through sort of a four-year degree, let's say. But even if you haven't, oftentimes the scale of the projects we're working on are maybe a few thousand lines of code that we write from scratch, okay? So we want to get some of that practice of looking at maybe some larger projects, reading them just like we read large novels. Again, to learn from other code that people have written and then not be afraid to navigate. Just like if I give you a book or a reference manual, you know how to flip through the pages and find a chapter that you're interested in and so on. So that's a few notes there. And yeah, just some notes here. Yeah, writing better code often reduces frustration, anxiety, and increases productivity. Go home happy. Yeah, I think so. I like that. So let's get on to it. Let's figure out, how to, write some better code. And again, today I'm going to focus on the understanding of code, more just tools to help you navigate a code base. But there are other things you might do, like measure performance, maybe the security. There's all sorts of metrics you could think about. But today we're just focused on the logical side of what is a code base doing here. Okay, so these 3 points here: understanding the control flow a little bit, wrestling with the scale of a code base, and then just a few of the human factors to keep in mind, since we're all humans. At least last I'm checking on here. So anyways, where to start? Well, let's take a look at some open source code base. Okay, so I'm going to be looking at this game here. It's a nice visual game. It's called Transport Tycoon. It's a game about moving around trains and cars and airplanes. And if you're not familiar with it, all the more better, right? Because this should be an unfamiliar code base. But it is a quite charming game if you do want to play around with it after the talk. So if you'd like to follow along at home or after this talk, you can download this because it's an open source project, right? And this is the way to practice if you're, thinking about starting a new job or just joining a new team or want to look at some other project. Open source projects are great. One, because you have somewhere you can ask silly questions online and not have to worry about it at work, if you're apprehensive about that. But again, it's a good use case. It's large enough. There's a lot of contributors, lots of different experience levels, and it's been around for like 20 years. So, it's gone through that arc of legacy and mixed with, modern C++ code. Yeah, and as someone's saying, just looking at this project, it's important to understand the why and how the code base evolved, which again is another kind of interesting reason to look at some of these long-lived projects. And yeah, if you have that documentation as to the why, that's incredibly helpful. Maybe that's a good question to ask. So keep it in mind some of these questions that you want to ask here. So anyways, looking at this Transport Tycoon project, it's a relatively large code base. Let's call it around 300,000 lines if you add up all the header files and C++ files of code. So, large enough that it's going to, not be something we can just look at in a day here. Okay. So I use this tool. It's called Clock, maybe for short, but Count Lines of Code, CLOC. And even just running this tool provides some interesting insights, right? I'm looking for a C++ code base, but you can see, hey, there's a little bit of objective C++ that snuck in there. Why did that sneak in there? So that might be kind of curious. Maybe it's for Apple's devices or something. But you can kind of see there's other interesting things here. There's squirrels. Maybe there's some sort of like scripting language here. The D is from CMake, as much as I like the D language. This is from CMake files that were built. But there's some shell scripts. So again, you get a good overview. So anyways, what we're doing today is just looking at tools and seeing all this information we can infer, which is kind of interesting. So anyways, let's jump into understanding the control flow a little bit here. And the very first thing we want to do is actually run our application. In this case, I've chose a game. You might have a web application, maybe a service that's part of a larger thing, but you want to be able to run it. Again, that sounds silly and obvious, but I won't assume it's necessarily always trivial to build code either, right? We have full build engineers to do this sometimes, but let's assume we can build this, right? So for Transport Tycoon, you can generally run CMake and then make and get a build of it. Now, when I'm first looking at code, though, one of the first things I want to do just to kind of anchor around the program is find where the main function is, okay? Again, that seems like an obvious thing to do. We want to see where the program starts from so that we can actually, get an idea of the overall architecture, right? You can see some things that are happening maybe before or in the main function, some things that are happening after the main function, and then try to find the main loop. Okay, so that's kind of our goal, probably the first time that I'm running through some project. Now, how do I find this main function? And if we just stare at this code, it's already a little bit interesting at line 21, right? You can see we've got this C calling convention here, main, and then it's returning to some other main here, which is a pattern you'll often see in games. But again, that's a good reason to try to read a lot of source code because you'll recognize these things. You'll also notice there might be signal handlers or other interesting things installed just from this little bit of code here. But anyways, let's just try to find main. Okay, where does it exist? Well, the first tool that I'll give you to look at here is using grep, right? So grep is a search tool. There's other tools like find, or I think there's one called like silver search or something like that. But grep is the canonical like searching tool on Linux that you can use to find things. So I want to grep for and do a recursive search for main here. And I find all sorts of main functions here. I find main functions that look like maybe they're part of the graphics system. If you know a little bit about OpenGL and graphics programming, I find main and what looks like Python, because there's Python mixed in here. So I find a bunch of different entry points into this project, which is kind of interesting. So 37 places to look for main here. Maybe main space with the parentheses gives me different results, but again, just searching here. But we can reduce our search a little bit with grep, for instance, by not including the binary files. That's what the -I does. And then just including the CPP files, because I'm pretty sure this is a C++ project, and I can find my main function that way. Okay, so these are just some ways to, again, start grepping around. We don't want to forget grep during this lesson today, because it will be helpful for us for just finding things. Okay, so that's how we can kind of grep for main. That might be a first thing that I do. But we can also make our life a little bit easier because, I'm going to assume that you have some build or able to build your software here. So while grep is a useful search tool, it's a little bit of a treasure hunt if I'm just trying to start and run an actual program. We can, again, just run our program. So, and hopefully we compiled with debug symbols. So I'll, mention that again here. And someone also mentioned, why not start with looking at the top level CMake lists makefile as far as doing the build? I think that's maybe where we're getting to for actually doing the build. But yeah, of course, our build system too is actually, there's the config files, and that gives us some idea of the project structure as well. Yeah, that's a great point. But I'm going to start us off here. So, on that point, going back to CMake and making sure that we did a debug build, again, to make sure we have debug symbols. Again, debug information helps us feed our tools, our debuggers, profilers, all these different tools, symbol name information. And, there's different ways, again, depending on what type of program you're trying to debug, that you can actually install or load symbols. So again, I'm looking at a game, which is a nice sort of closed environment, but maybe you're working on some microservice where you're, gluing in a binary file, or some project that's always running and release that you've got to, peek into. There are ways to install debug information. So I've linked an article here on just some more information on debug info. So anyways, let's go ahead and assume we have our debug build and can attach a debugger into it. And then again, we'll repeat this experiment to find our entry point here. And as somebody is mentioning here, some code bases are multi-platform and involving embedded firmware for various boards, Linux and Windows. And I'm mentioning that because that's going to be a little bit interesting here, because why don't we actually jump into GDB here? Actually, I have my build folder here. You can see for Open Transport Tycoon here. And I have my binaries. Let me just do the else. Here it is. So Open Transport Tycoon. And let's find the entry point. And again, holding on to that user's comment, JB, about multi-platform systems. Let's run GDB, and then I'll pass in Open Transport Tycoon. And you can see we're reading in the symbols, so we know we've got our debug build and I'll just do a start here. So start's going to put a breakpoint at our, our main where we think it is, or where it knows it is actually. And here it is. I mean, I can see the actual file here. I can see there's actually a Unix main. So in this particular project, when I was just spending a few hours looking at it, there are different entry points for Windows, Linux, and Mac, for instance. So that's exactly correct. That different systems have different entry points, and especially when you get in the embedded firmware world, sometimes it's not always as obvious as main here. So anyways, when I start this, I am at the main function. There's many primers on GDB. You can get sort of the trace here. I'm going to shortcut this just a little bit, just so you can get the visual view here, and you can see the layout here of where we're at here. So here's our main. We can go to the next function, and so on, and eventually get to this transport tycoon main, which if we step into, again, looks like it's passing in some arguments and starting our game here. Okay, so anyways, I'll just hit continue just so we can see that this eventually runs here, and we have our project up and running here. So the debugger is going to be one of my favorite tools for just understanding a code base. We can see this project running. Let's just go ahead and start it here so that we can see it's running. And then maybe something, maybe I want to just pause this since I'm in this sort of game loop. I can do Control-C, and we are somewhere in our project. Okay, it tells us we're in a sleep here, and I can do BT to get a stack trace, and it's going to give us some information here, but I really want to just see the source code here. So I'm just going to type finish here. That's going to sort of finish every function until I get to something that I can notice here. Okay, there's some sort of sleep, and then you can just kind of keep doing next for a little bit until you find something that looks interesting, right? And this is this sort of step-by-step debugging process. Okay, so here's interesting. I mean, I found a while not exit game loop once here. So let's kind of step into that here. So I'll do next, and then I'll step into this function here. And again, I find this sort of loop once function. So it looks like the program's structured in this way that I just have a sort of update function. That's what this loop once is, and that's just going to be called continuously forever and forever as long as we play the game. Okay. Now again, there's interesting stuff about the architecture. There's this if-def mscripten, which is, well, giving us some nice comments here about it being event-driven. Okay, so there's some event-driven structure here. Events maybe are passed around. Okay, so we can already start to infer lots of interesting information here. But perhaps what's most important is I've learned about this loop once function. So I could just put a breakpoint at loop once, and then I can keep hitting continue. And I'll type it out here just to slow down a little bit, continue. And I could just keep doing C or hitting enter to repeat that. And my game's running one frame at a time, one frame at a time, one frame at a time. So already I've learned a little bit about the structure of a game. I've learned maybe some important things, and then I can walk through this and find some interesting things. Okay, so that's the idea. Step-by-step debugging here. We've found something interesting here. All right. And as somebody is agreeing, yep, just finding little breakpoints here. Now, this, as mentioned, though, the comment doesn't work maybe as well for networking heavy applications, sadly. So we're going to want some, I'll give some advice on that right now. I'll give it later as well if I remember. But for networking applications, hopefully we can mock something up or look at the tests in some of these applications that maybe it's not as clean, right? If I'm building a game that has, let's say, 1,000 online players where we want to see how that infrastructure works, it might be a little bit harder to do that with a sort of step-by-step approach. But maybe we can mock it in sort of a test and kind of walk through that and see how events are passed along, right? We can gather some information, which would be the goal here. All right, so let me exit out of that little step-by-step debug there. And again, I have videos here for the slides, so again, you can follow along later. But what's also kind of neat and really an important theme here is, sometimes we don't want to always do things from scratch. We want to kind of play our game for a little bit and then attach that process. So I want to do that a little bit quick here as well, because we're going to repeat this a few times here, right? Like this time, let's just run the game here so we have it running. And let's actually step into the game so we can kind of jump in really quickly. And I'll just keep this window. I'll move it off the screen for now. But what I want to do is actually attach the debugger to this process here. So let's find out which process that is. And this is for the Open Transport Tycoon process that's running. That's the process ID. And let's attach GDB here to that process. And oops, it says operation not permitted. So I usually need to be a super user to do this. So sudo, I'll type in that secret password here. And I should be in my game again. I should be able to hit Control-C, go in the layout, and basically repeat this process again here for my game. Okay, so that's the idea here. Again, attaching to some process here. Okay, let's see here. Let's just exit that. Okay, and this should terminate my game, but that could be another way, while something interesting is happening in the application to get it up and running here. Okay, let me terminate there and get back to the slides. All right. So anyways, you can see that recreation there. Anyway, so here's your little cheat sheet for some important things for step-by-step debugging with GDB. So just a little card here. Now, inevitably, though, when you're doing these experiments, you're going to do like I did, and you're going to do next and next and step and set a bunch of breakpoints, and then you're accidentally going to step over the function that you wanted to investigate, or maybe something important happened in the game or whatever system you're looking at. So it can be really handy to also be able to go backwards. And GDB and UDB, which is another tool, do allow you to do sort of reverse debugging. There's actually another tool called RR, which allows you to do reverse debugging. So, you can play the reverse card and go back in time, which could be super useful, if your program's in a state that you didn't want it to be in. So I just want to mention this. You can do the same sort of experiment we did with GDB, but also reverse step or reverse next, for instance. I like using Undo's tool, UDB. That's the one I use most. So, folks can grab the QR code if you want to try it out. It's the same commands as GDB, but again, you've got the ability to go forward and backwards. So I'll just play a little recording of that for you as well. I'm just kind of curious, have any folks heard of, are folks using GDB, UDB, LLDB? Just kind of want to, debuggers is something I'm passionate about. So let's see what folks are using. So LLVM stack with LLDB, GDB mostly. Anybody using RR or other free tools? GDB, yep. Yeah, I think GDB 16, I think, was just released recently too. Heard of RR, but never used it. Yeah, cool. Yeah, so we could go backwards. I'll give you folks a preview. Just another tool to add to your tool belt here. Visual Studio Debugger, yep. I think Visual Studio recently has a thing where you can just move the stack pointer back to, and it'll do reverse. I think I saw somebody do that. I haven't run Visual Studio recently. GDB users as well. Yeah, cool. And some folks have heard of Undo. Yeah, so and C-Line, yeah, has a nice front end for GDB. Visual VS Code, the text editor, also has some integrations for GDB. So I encourage folks to definitely check out all these tools. Yeah, definitely check out C-Line as well. But the basic idea, if you want to be able to record and replay something, is basically to use a tool like Live Recorder. If you're using UDB or in GDB, you just type, again, record, or the same with this Live Recorder. And you can actually record specifically when you hit some symbol, like the main loop, for instance. You can type out the fully mangled symbol or just the regular one, and it'll usually find it. But basically, I'll play a little video here just to show you going forward and backwards. Here, let's up that quality a little bit here for you. But basically, this is a way to play a recording of something that happened. So you just turn record, and then you're able to jump into your debugger here. This is in UDB, and just do reverse continue. That takes you to the very start of where you started recording. You can do next, and then you can do reverse next, and then you'll notice me going backwards here, which is really cool because then you can inspect the state here. I think there was no real state here in this particular main loop here, but then you can just kind of see how things change. So again, another tool in your tool belt to see how things are happening. And this, the reason I'm mentioning this is if you're first understanding a program and trying to understand what's going on, it can be frustrating if you're deep into investigation and then you can't go backwards. Especially in the game playing world, I've had that experience. So anyways, that's a little bit on time travel debuggers. Okay, so I've done a little bit of work here with our debuggers. And the other note I'm going to make is, as you're doing this, keep a journal. I kept a physical journal with me most of the time. These days, I also keep a Google Doc because that's easy to search. But as you find interesting functions, log them somewhere, a Google Doc or whatever is appropriate in your company, in their internal system of things that you learned here, right? And you can grep, again, that tool grep for asks, maybe with asterisks that are open or that you understand, or plus signs of things where you kind of scratch your head and say, well, I'm not sure what this function is, but it's called a lot. Okay. All right. So cool. We're able to find the entry point. We can kind of go step by step here, but how else do we know what's important in a code base? Well, this isn't particularly a performance talk, but we can use profilers to try to figure out what functions are important. And one way to do that is to see what sorts of functions are called, for instance. So we try to find the hot function. So this tool here, perf, is a performance profiler. Basically, it'll tell us how often we execute some function by sampling the stack, the instruction pointer, basically, over time and seeing how often we're within some function. And again, that can give you some interesting leads of, oh, these functions are important. Or it might be important just to see which function was called, exactly once. And then you can kind of work backwards from there and figure out why it's called once. So sort of the hot or the cold paths you can sort of see. So anyways, I have another little video about how to basically record your performance and again, attach to a process, right? You'll see this theme here where, most of the time you want to just run your project and then attach to it at some point. So -P and then get the process ID in some way. Okay, so I'll skip that video to just keep us moving here. Because I want to show you this other interesting suite of tools here. Again, sort of belonging in this profiling domain, these dynamic analysis tools. This one's called Valgrind. So it's basically a tool suite of tools. Many of you probably know, or if you've used this on Linux, this is a great tool for finding memory leaks, but it's got a whole suite of tools for basically seeing what a program's doing. And some other folks are mentioning some profiling tools. UF trace, which gives us flame graphs, which is a nice visualization, yes, for seeing what's important. Love that tool here. Other folks are mentioning org mode for keeping notes, which is exactly what you want to do. So as I'm showing you these tools on profiling, what was interesting, what commands you ran to gather that profile, right? This thing that I typed out here. These are all useful things to keep in your journal as you're understanding your code base and saying why you did it. So anyways, this particular suite of tools, Valgrind, has a tool called callgrind, and it's basically a tool. I'll show you the visualization here that'll sample every 10 million basic blocks. So every few your curly braces are basically what define basic blocks, roughly speaking. but it'll basically tell you how often you enter those, right? Just like the sampling profile. So you get a visualization like this. And I'll actually open this up. I've got the tool available or available here. K-cache grind. And let's see, if I run it in the directory where I've gathered a profile, which I think I gathered one here, you'll see it'll load up basically some information about what happened when I ran Open Transport Tycoon. So again, another nice visualization tool. You can see how many times it was called here. There's various columns here, so that might be one way to sort of organize what's important. You can search here. What was the thing we found? Loop once. Okay, there it is. It's called 9 times, so I guess I did a short little profile here. But we can actually see this tool, which is really, really cool here. And you could click on the functions. Let's see if we can find something of interest here. maybe, I don't know, redraw the screen rectangle. That's called, I don't know, 32% of the time. I can double click on that. I've actually got the source code here, which I can take a look at, or at least I know where it is, right? It's telling me exactly where that graphics function is. And I can, again, look at it here. So there's a nice visualization, again, to sort of show you the story. Again, I can look at the source code, which is our ultimate truth. But again, sometimes these visualizations are helpful just to explore the code, right? And you can use various views here to split the layout and again, maybe see what functions you're called and how often, which again would give you an idea of maybe what's important in a code base. Probably what's of most interest is just to see how these are, what family does redraw screen rectangle belong to? Well, it's part of some graphics library or graphics namespace. So again, it's giving you a hint of something going on in the system. So anyways, that's just a little preview into that tool here, so we can kind of visualize things. So again, this could be very useful at the least if you just capture a screenshot, right? As I'll demonstrate, as I often do, like, I guess it's not going to show up on the recording so much, but just take a snapshot, hit print screen of this investigation that you did, so you can remember what was important, what functions were calling into it, what was the program flow. Is it an infinite loop? Is there just a function called polling for events? You can capture some of these details visually, which is very nice. So anyways, okay, so this is your call graph, your functions that were actually executed, and you can visualize them. And again, this is a nice tool. And these are tools available on Linux, but there's equivalents on Windows or Mac if you search around. Okay, so again, you could view this source code here, but again, your real goal, again, with some of these tools for the exploration is, again, to use them also to help you set breakpoints in tools like UDB or GDB. So once you find out they're interesting, like this tick function or loop once, you know to revisit them. Okay, so those are a few tools for understanding the control flow. Let's talk about how to deal with the scale of the software here. So again, we're looking at a piece of code that's 300,000 plus lines. So how do we reduce that scale? Basically, is the question that we want to answer here, right? We've seen those visual tools, which are very nice. So that's one such solution. I have a few silly ones here. First and foremost, getting a 4K monitor or something, because you're going to have a bunch of these windows and tools that I'm introducing you to open is really, really useful, right? And you're attaching to processes, so you want your debuggers and profilers. I mean, if you can afford the budget for it, justify to your manager that, to get an external monitor. Sounds silly, but that was one of the big wins here. So, also on that sort of pragmatic side, being able to manage your screens or windows. I use Tmux and Vim to split my windows. If you're using tools like VS Code, C-Line have different ways to, again, split and manage your windows that are great. So definitely, use those tools as well. But one other kind of interesting thing that I started doing more frequently is generating my own documentation. So, I noticed in this particular project that there wasn't, there is a wiki and there are, GitHub and so on, but you can actually generate documentation and do it in a pretty uniform way that you get used to, right? You can have a configuration file for how you generate your documentation for yourself. So I use Doxygen. You can use DoxyPress or other variations of documentation tools to generate your own documentation. So again, this is just basically, it's as simple as doing Doxygen-G and then running the Doxy file, and then you'll get your own documentation. Okay, so again, I will, let's terminate that. And then I will show you after running my Doxy file here, I get an HTML folder. And then I just open up the index. Let's open that up here. And I'll bring that down so you can see my window here. And just like that, Doxygen brings in all the markdown files. I've got my classes, the search feature, which you can enable. And again, it's just another tool for being able to search. And I also find this helpful because if I can click on the documentation, right, I can bookmark this URL. So that can be helpful for, again, your own personal code journal. You have your own, set of documentation that you can link to, which is nice. So just a little tip there of something that I started doing to help Russell with scale. And there's also other useful things that these documentation generators can do. For instance, being able to look at the inheritance structure. These are things, wrestling with this code base. I wrestled with LLVM for a long time, and I can tell you, for some code bases, these inheritance diagrams are really, really handy. And you can click on them and they're interactive. So again, you can get an idea of how things look. You can also get an idea just by looking at when you have a bunch of the function names listed, right? How are things named? What are the verbs? Is it a is function when, evaluating a Boolean value? All these little things that'll help you, with your code reviews go a little bit smoother here. Yeah, and somebody else mentioned, on this idea of documentation generators, having the commits and being able to look at diffs. Yep, that's going to be a pro tip here to see how the code changed over time, right? If you have the Git history, absolutely. And yes, this for Doxygen, as mentioned, does need the dot tool to generate it. There's various dot file generators, but at least on Linux, just using the dot tool will give you these diagrams. Yep. All right. So again, as mentioned, you can gather a lot of observations or make rather some observations about the code base, the naming, some of the styling things. Are they using, here, uint32_T's. They're using, fixed size int types for returns. Do they have their own string type? What's a string ID? So all these interesting questions that you can see just by, looking around at some of the code that might be faster than looking at all the source code with implementation details. Now, occasionally there is also code, I shouldn't say occasionally, but often there is code that you don't own. Sometimes it's compiled in a shared library. So what do you do with that? Well, I mean, first and foremost, you might see some functions that you don't have access to the source code, but you can usually gather what the libraries are, and you can either download those libraries like SDL, which is a graphics library, OpenGL, DirectX, some of these graphics APIs you might have heard of, libpng for PNG files. Again, but the way to sort of uncover this, you can use a tool known as LDD, which will tell you what the shared object files, or DLLs for my Windows folks, are part of the project, and that can be useful, again, just to have a hint of what the dependencies are, maybe some idea of the project structure. Is there code that we own that goes in here? Why did that come to be? Is there a plugin system? Some of these ideas that, again, you can kind of decipher, just again by understanding a little bit more of the structure here. So another favorite thing that I like to do is use a tool called ZealDocs. I've also got it up here. And you can download various documentation sets for various APIs. So if you're using OpenGL, or even just C++ here, offline documentation is a lot faster to browse. You can generate this for your own project as well. So again, just something worth mentioning that's been a real time saver for me. So let's see here. Yeah, and for security reasons, never run LDD on untrusted executables, right? Yeah, so make sure it's the code that you own, right, from your build folks. So, maybe there's still too much code at this point, maybe still too much scale, but what you, again, can try to do is reduce what you're looking at here, right? Run the tests, run the examples, the suites. Maybe just find the examples from the API that you're using. So again, these could be some useful ways to manage the complexity. And often test cases, if you're lucky enough to have them, will give you some insights into what systems, what's the minimal subset of systems to do something useful, right? If it's sort of a unit test of sorts or behavioral test. So anyway, that's the idea here. I think we are going to have a wave of other interesting source code visualizations. This is called a software city. It's a metaphor for software. You can imagine a block being like a namespace and then a building being a source file. So there's going to be more of these tools, I think, showing up. I think it's a really interesting space. And I'll also just mention tools like Clang Tidy or Indent for formatting code and finding stylistic things that might be different here. Some other recommendations, studying design patterns or looking at other code. In particular, there's a great book here called The Art of Open Source Architecture. It's just an open source book. So maybe you're not familiar with games, but you're going to go work on a game project, right? Look at this book and it'll talk about what a small game looks like, or what Vim looks like, or source code. All these different things here will be useful. All right, so last topic here in the final few minutes, some human factors. Okay, so we understand a little bit some tools and understanding control flow, working at scale, but we are humans, so how do I dive into a project? I need to be motivated, and really the way I think about this is, what's a first good task? I just need something to do. I can't just grep around a code base or step-by-step debug through it forever. So in a project, like an open source project, if you're lucky, usually there will be some lists of tasks here. So again, for Open Transport Tycoon, you can go to development, you can go to the bug tracker, or issues in the GitHub repository, and you'll notice a bunch of maybe bugs that can be fixed. Even better, if you're lucky, you go to labels, and if we kind of scroll around here, look, there's one here that says good first issue, good for newcomers. Okay, so if you're just getting acquainted with a new project, having some actual problem to work on, good first issue probably means whoever created it can help you. They know what it is. They probably know how it can be fixed, but it's just not high on their priority list, and they're leaving it open for you to dive in, fix a problem, and do something simple, right? Maybe add just an item to a menu, for instance. That this could be a good issue here. So yeah, and as folks are mentioning, speaking to team members, getting a sense of who works on what areas, that's great. Shadowing other engineers on your team to see how they work and go through a code base, awesome tool if you can do that, right? Say, hey, I'll buy you coffee if you let me watch you program for 15 minutes, right? You'll learn a new tool that somebody uses, right? It can be incredibly valuable. So anyways, my tips on the human factors, right? Finding these sort of small tasks to work on are good ones. And again, if you can't find these first tasks, again, our friend, this tool grep that we learned, searching for to do or fix me or later, these sorts of keywords can often give you some hints of things that maybe didn't make the issue tracker. So that's the idea here. You might also do some other little things like fixing warnings in code. Again, it's not glorious, but these are just a few different ideas, right? So and another little exercise you can do is just clicking on like a menu item and using UDB or GDB and seeing what changed, how did you get there, right? And make it do something else. Change the callback function, right? You'll get a different idea of how things work. All right, and then on the human factors, going along with the comments going in the chat here, just be nice to everyone on your team, right? Empathy goes a long way when working on teams. But I would say, don't be afraid to ask, especially if you're just joining a project or working on a large code base, right? Somebody probably wrote that code, or somebody knows the person who wrote it or can point you in the right direction. So asking others and getting a sense, as mentioned, of who works on what is a good idea. And if you're a senior engineer, right, maybe you already know all these tips and tools we've talked about today, right? Making a note of where these reoccurring questions come from is generally a good idea, or creating in that issue tracker you have some good first problems for folks to work on. And if you're allowed to screen record your sessions, or let juniors take a picture of a whiteboard if you walk them through the problem, that's a really great idea, right? And sit down your junior engineers before they have to ask for help, right? If it's their first day, give them a run through, right? Have that plan if you're able to. All right, so a little bonus round here. Yeah, and typo and always be nice. Yeah. What did I say here? Always and be always, yeah. Be super nice to your teammates. Yeah, so the bonus round on AI here, I'm not sure yet, because these tools are so new. But what I can say is, if you have access to the enterprise AI tools, right, the ones where it's safe, right, and check with your manager, your team, somebody who is an expert in these things, if it's safe to paste in some code because you're really, really sure that code's going to summarize it and not, send that data or train on that data somewhere, that could be a useful thing, right? At scale, I don't know. Can we paste in a 100,000 line code base? Maybe not yet, but in small snippets, it can be another tool. Now, code summarizers, there's tools like Chat DBG to help with debugging messages. They're going to continue to improve, so just kind of keep an eye on that space, I should say. All right, so I got a bunch more resources, tons and tons of tools, debugging talks that I've given some other folks. I like Greg Law's talks. That's why we've got, the UDB stuff in here, because they do some cool stuff there. So you can check those out. But again, overall, learning how to attach to a live process, step-by-step debug it, do some profiling to figure out what's important, and then try to reduce your scale from there. Use visualization tools, document, take notes as you're learning, bookmark things. These are all important things to do. And again, as always, when you have a really, really big problem, try to break it down to a small problem, that first sort of issue. That can be really, really helpful for working through your code. So with that, folks, I want to end us on time, since I know some of you are getting started with your evening. I'm happy to stay along for questions as long as they go, but hopefully that was useful. Hopefully you found one new tool or got inspired to try one new tool today to understand your code base. So yeah, thanks for your time and attention, and I'm going to hang around.
Thank you. Thank you for your talk. This is one of the top topics that I'm interested in terms of how can we improve. So thank you. I totally relate to this talk. Thank you so much. I let others to chime in if they have questions. Before I have like just a few comments, especially on the AI, to just have experience in the past 3 months, kind of supporting what you said. But I'll let others first ask questions or comments.
Yeah, absolutely. Yeah, and feel free to unmute, or I'm keeping an eye on the chat as well if folks want to type in if that's easier. Let's see, can I go back to the resources? Yep, yeah, I'll go back here. So most of these are, debugging talks, GDB stuff. This debugging Linux C++ has a ton of tools. If you haven't done any time travel debugging stuff, Greg gave a talk here at Meeting C++ that could be of use. So yeah, check those out. But it was Greg's 2016 talk that really got me to dive into GDB and learn as many things as I can.
Yeah, Greg has a ton of resources. One of the things that I'm kind of amazed by GDB, and Greg has few short videos, is the Python integration and automation with GDB, which is kind of insane. Like if you control that part, you basically you're nailing it in terms of like productivity. So I highly recommend looking for that talks and small videos, and maybe subscribing. I think I'm subscribed to notifications from Greg, so this is why I'm seeing that. So this is a great resource. So yeah.
Yeah, there's a really cool video if it's called Reanimating a Zombie with Time Travel Debugging or something like that. You can do some cool and nuts stuff with debuggers. I'll just leave it at that.
Yeah, it's really cool. Debuggers are not boring. Not it's like something very different. I have a comment about AI because
Please, yeah.
being fortunate to work in a company that provides me access to enterprise tools for AI, and I think this is a huge productivity gain for us as developers in terms of understanding the code. So there are multiple ways to approach these tools and utilize it for our purpose as developers. One of them is, can you explain me the code? Can you write a sequence diagram? Can you write mermaid or whatever diagrams of the inheritance, what is the flow of data? And it is mostly doing a very good job with some caveats and issues in specific code bases, which are very complex, and LLM find it very hard maybe to grok it. Remember that what I heard is that LLMs are in this software engineering benchmarks, they're usually trained on Python. Just remember that. But it's still working. It still work well enough on C and C++. I'm using C++ mostly, so I'm kind of amazed. But there is a CPP cast recently talking about Anthropic. So there's Anthropic employee that speaks about that. So it's really interesting to hear from a Anthropic employee about that. But yeah, explaining the code with AI, I think this is, and it's only going to get better. So I think this is, for me, is a huge, not only for me, but if you just listen to others, they will have good experience on that. So we are definitely in a amazing times of this whole domain.
Yeah, absolutely. And I'd love, if folks know more or find stuff that's useful on AI to keep learning more about it. Because it's so exciting. We're right in the middle of, the next iteration, I guess, or large increment of software engineering, I think.
Any other question, comments before we let Mike go?
Yeah. Got the top was pretty informative and covered a lot of things that proved useful for the work that we do. A lot of this is not centrally collected, so
I think you. I don't know if it's only me, but you're breaking up. I don't know, Mike. Can you?
Yeah, it might be easier to type in.
You want to type that?
Yeah. Right. Yeah. Sorry about that. I'll just mention someone's messaging strace for monitoring. Yeah, their system call, ltrace for libraries, hotspot, perfgui, all excellent tools. And somebody, I think, who was asking the question was also talking about developing code visualization tools for this very purpose. Yeah, absolutely. And as I mentioned, I showed a visualization software cities. So sometimes it's interesting to look back, 10 years, see what the researchers were looking at and what metaphors or tools maybe were available, and thinking about, how useful those tools could be. Do we need better visualization tools, things that do more than UML diagrams, things that can really visualize software. In particular, I'm thinking a lot about concurrency and visualizing these things. I didn't talk about it as much, but a really useful thing to do is that step-by-step debugging, but to display or basically write a little Python script that's printing out, how many threads are running, what state they're in. Those could be really, really useful things. If nothing else, just to get an idea of, again, the execution or the load on your program. Are there tons of threads spawning? Are there just a few worker threads? You can gather some nice insights. Yeah, and anybody who writes tools, I think that you're my favorite people. I'm a tool writer myself, so I love making my job easier. So
tools are important. Yeah,
absolutely. Yeah. So all the AI stuff, I wrestle with the AI stuff because I'm a teacher, so I have to make sure students learn things. But we also have to use them as a tool, which are going to be incredibly valuable. Let's see. Here's I think the comment. I've pivoted the visualization work to vibe coding, generative art from source code. Okay, cool. I'll check it out. vcshowversal.app. Let's see. Could you please suggest tools for restructuring or re-architecting legacy code bases? Yeah, so there's traditional tools, tools like linters, or tools like CPP check, or these types of things. I think what is it, Sonar, or a few of these other companies, even I think Sea Lion has refactoring tools, and like ReSharper and stuff that'll often give some recommendations as far as like, if you have some pointer or something, it'll recommend that you use, this smart pointer or some of these things. So those types of linting tools definitely exist that can be useful. As far as re-architecting the actual legacy code bases, that's a good question. If I I mean, that's one of the things that AI, I think, will eventually get to and say, hey, I recognize this pattern. Have you considered, something similar?
Yeah, I agree. I agree. Start with tests. Let the AI write the test for you as much as possible, so you have some confidence if you don't have tests.
Mm-hmm.
But I agree. AI, I think, would help. It's only gonna get better. So
Yeah, I'm trying to think of another thing to think about, so I live a little bit in the gaming world and graphics. So sometimes if you just want ideas for restructuring or re-architecting legacy code bases, you can look at when there was like a generation leap, like let's say from DirectX 9 to 10 or something, and find talks about that. So whatever your domain is, maybe you could look for when there was an API change and try to find a talk. There's lots of CPPCon talks. I'm sure there's probably been at least one talk at this meetup about refactoring or looking at legacy code, or there will be in the future, and someone should volunteer for that.
yeah,
But those can be great ways just to get ideas. And that's how I learn trends. And again, reading lots of code informs how I write some of my code now. Let's see, a comment on how it's funny and twisted companies have testing as an afterthought. Yeah. When it really should be, a lot of the devs and seniors writing the tests. I agree. We always need more tests, right? That's how we increase our confidence in software. I think there's another world of tools. Again, maybe this is something AI will help with, like theorem provers and stuff. If you look at like Z3 and Coke and some of these different theorem proving languages that are, not necessarily easy to use right now, but with AI assistance will really help us on the testing for correctness, and then tests for, as mentioned, we can have the AI or at least write us some basic unit tests to have something. Yeah, if your code base has no tests, that's needs to be fixed. So look at Catch and Google Test and other testing frameworks out there.
yeah. Thank you. Anything else, folks? Okay. So thanks, Mike. It's great having you. Great talk. Thanks a bunch. Hope to see you again.
Absolute pleasure. Thanks again so much for hosting me, Gobi,
Thank you.
and we'll see you folks around.
Take care. Thanks, everyone. See you next time. Bye-bye.